My diodes came in today, so I can start working on that bug whacker. And they came in from China. They're 4,000 volt diodes. And I verified this part number here. So I just wrote down 4,000 so that I can put these in the drawer there. Should I have any left over, I can put the tag in there. And they're not very big. They're about the size of a 1N 4007. Alright, I took apart another Harbor Freight fly swatter that my son had, and it didn't really zap very much. But if you look at this thing here, it has 3 diodes in it. It has 4 green capacitors and the big output capacitor here. And up on the top is a resistor, a blue resistor, and the bleeder resistor is off to the left as you're looking at this picture. And then the high voltage leads comes out through here. I'm using the play touch, so my magnifying glass shows that I'm in focus. But you can see on the board here, there are places for other diodes. Oh, I've got those diodes as I showed. They came in today. They're 4,000 volt diodes. This thing seems to put out a lot of voltage as far as the snap is concerned, but I think it's only about 1200 volts. Now, I count 3 diodes, and let me come back and verify that by getting my magnifier right in there, and I'll be back on the video in a minute here. Upper left hand corner, it looks like D5. To the right of that is another diode, and then a third diode, I believe it's D4. Yes, D5, D3, D4 in that order. And you still see some symbols for other diodes that can be added in here. And over here, it looks like right in this area here, it looks like 1 kV and 2 kV. But if you've got 3 diodes in there, it's got to be a heck of a lot more than 2 kV. So let's put a meter on this. I got that high voltage probe that was sent to me. 6,000 volt full, max range. We'll put a meter on it. Before we do that, trying to get you a good image here. There's a D2, there's a place for a diode 2 and another resistor, but they don't tell you what the value is. So it looks to me like this thing has the capabilities of being a tripler or a quadrupler. Now, I could experiment with this and try to do that with this board here, and maybe adding some of these 001 10 kV caps that I got in there, and those diodes I showed you in the beginning of this video. There'd be plenty of room in this handle. This was a D-cell version. That could drop right in here. These wires can connect up to the input. Just remove that spring there. This end here could be coupled to the small wooden donut things that I made up, and put my grid up at this end and utilize this handle. The problem is I've still got a very long handle, and it doesn't make it convenient to carry it around. But this could be rechargeable. I would have to lop off the back end of this handle here and put a flat plate across it so that this recharging port here would stick out And then I think that might fit in there. It looks like it might, but I'm not 100% sure. I'm hand holding this, you know, and I'm always preaching, use a tripod, use a tripod. All right. Well, it's not perfectly lined up, but I think that'll snap in because it's got play in there. And then when the battery cover snaps on, right here, it'll be fine. And the little button would be used, but instead of this button turning, you know, switching this circuit on and off, I could bypass that and have this here which is rechargeable, put out its 3.7 volts or 3.8 on the no load, and do it that way. That would be a better way, perhaps. But that's a mystery. Let's see, am I still on Mac? Well, yeah. That's a mystery. And it looks to me like this is the most versatile board, but let's see the size. It's a longer board than the other Harbor Freight that I took apart. This is out of the second Harbor Freight. So this thing is in constant development. What I'm going to do next is I'm going to put my power supply on this, get you off of macro here. I'm going to put my power supply on here, set this for 3 volts, because that's what it originally had, was 2 D cells in it. Put the probe on this, and we'll see how many volts this thing will generate. So let me get you on a little tripod here and we'll get the equipment hooked up. I'll be right back. By the way, I've got the air conditioner running here in my shop, trying to keep cool, and we got the bedroom air conditioner shut off, and I'll only put that on when I go in there. They'll go to get on. Yeah, can't even talk today. When I go back on the computer. Then I shut this one off, go in the house, and turn the other AC on. So let me get you hooked up here. I'll get these capacitors put away. We may not even need these diodes right now, but if I choose to add them in these empty diode slots in here, be quite interesting. But I think the voltage, which this is another one of these capacitors, I looked at it carefully, that are unmarked. So I think I could put some diodes in here in the empty slots, but I don't know what the resistors values would be, and I would actually have to try to draw out the schematic of this, and I don't think I can do that. I'm not good with printed circuit stuff and tracing it out. So I can make heads or tails of this circuit, which at this time, not able to figure it out. After all, a tinkerer and experimenter is all I've ever been and all I ever will be. Stay tuned. I'll get the high voltage probe out, get you on a tripod. Don't go away. I will be right back. You can be sure of that. Alright, I got the high voltage probe hooked up. I've got my 3 volts going in I've got the meter set to DC volts, of course, for the high voltage probe. And we're getting about 1400 volts on this. So this is the highest Harbor Freight one I've had. The one before this was that other circuit board I showed you, which was getting about 12 to 1300. So let me see. You may not be able to see the meter on that. So we're just going to have to do it in two different shots here. 1377. 1377 volts. Let's get you over to. Alright, now I'll push the button again. I'm holding the button. That's what I get. That is what we're getting. 1458 volts. So roughly almost 1500 volts. Alright, we're back on macro here. I just disconnected the positive lead off of the bug whacker here. So that's what we're getting out of here. Now what I could try to do is take the board out and try to draw the schematic, but you know what? I don't think I'm going to be able to do that. It's beyond my capabilities to do that. It's not possible for me to make it voltage doubler and tripler and even quadrupler in here, and because those extra diodes, there's 3 of them in there now. I'm not really sure how this thing is, unless this transformer is low output, like maybe a couple or 100 volts, maybe 300 or 400 volts, and they're tripling it up. In other words, let's say it's 500 volts coming out on the secondary of the transformer, and if they're using a voltage tripler, that would bring you to about roughly 1500 volts, roughly. And these little green capacitors, which were not in the other 2 Harbor Freights that I scrapped, can't be high voltage capacitors. And these little things here, I used to use this type of capacitor way back in experimental things. The little green flat jobs there, I think they're Mylar. And they're low voltage capacitors. You might be getting 25 or 50 volts rating on them. You know, that's my experience anyways. And this big capacitor to the left here is your main output capacitor. So I don't know what the capacity of it is without taking it off the board and measuring it. But I have one similar to that I pulled out of the other Harbor Freight and could measure the capacity of that, but that doesn't guarantee it's the same thing. So on this horrible, hot, humid day, I figured might as well fart around in the Tinkerer shop today. And this high voltage probe, I'll tell you, is a lifesaver. You know, I don't really have to make one up now. As far as the voltage, increasing that voltage, yes, I would like to be able to get the voltage up to about 4,000 to 5,000 volts, but you're not going to put that across this capacitor here. I would probably, if I was going to do that, I would probably have to do away with this whole circuit here and get myself a different transformer altogether. And do that. There is a confusing part of this. I don't know about this circuit. Let me get a magnifying glass and before I put my foot in my mouth. The confusing part is, this is the second board I was experimenting with, 1300 volts out, that I was going to use. Okay, if you look at the bottom of this board, this is your primary side for your oscillator, which oscillates the primary and creates a voltage, alternating current voltage, and it's a step-up secondary. The problem is very confusing here as to why they're using, there's 3 taps on the transformer, on the secondary. That don't make sense to me. The outer edges should be the secondary, but what the heck is the center tap? Or if they're using these 2 windings for the high voltage, what the heck is this one? Or if they're using these 2 outer windings for the high voltage, what the heck is this one? On the primary, yes, you need that for an oscillator circuit. But why on the secondary, I don't know. And that's why I'm having difficulties making a voltage doubler for the output of this, because it's using a tapped secondary, which I cannot understand why they're doing it. If I had a schematic of this, I could understand it. I can grasp the theory behind it. But without a schematic on these solid state things, I just cannot trace them out. On this one, I can't tell if this is a tapped secondary also, but as you can tell, the board is a lot bigger, and it looks like it has more features on it, but the output is probably just 100 volts more across here. So this could be a tapped secondary also. That I don't know. I'd have to pull the board out and look underneath and see if it's configured like this, because you can see this is the secondary. This is your high voltage here. This is your primary. Your 3 volts go in. This is your transistor right here, which oscillates your AC, such as it is. It won't be a sine wave. It could be a square wave or modified, some kind of a square wave. The point is, it's alternating positive and negative, and therefore transformer steps up the voltage to whatever the output voltage is supposed to be, depend on the ratio. Okay, so right now we're going to just sit with this for a while. I may pull this out off camera, not necessarily today, and try to figure out what these other places are for diode. And I believe 1 resistor, maybe 2 resistors in here. It sure is quite involved for a Harbor Freight. It looks like it can produce more high voltage because they have places for at least 2 more diodes. There are already 3 diodes in here now. Okay, that concludes the video for today. For your entertainment and boredom, thank you very much for watching. Keep cool. Who knows when we're going to get outside and do anything on Uncle Dorkel's body. So, I'm going back in the house. I'm going to shut the AC off here now. Give it a break. Turn my power supply down. Shut it off. Shut my... This is my pilot light, so I know I didn't leave anything on. Alright, these diodes definitely can be used if I ever want to make a high voltage power supply or whatever. I don't need to go into a bug whacker. If I can use some of those diodes on this circuit, alright, but I don't want to put anything on here and mess this up without understanding how they did it. And like I say, there's at least a place for 1 or even 2 resistors, but those are not, there's no values marked on the board. It just silk screened on the board showing a place for a resistor to go. So There's a possibility that this circuit board might go to a higher output bug whacker that is not sold by Harbor Freight. So we got a messy workbench here, folks. And by the way, this radio, okay, it's a local station with the oldies playing. Radio's been working good. I put it on every once in a while and I just listen to a little bit in here. All right. At least you're looking at a sloppy workbench. You're not looking at an ugly kisser. Take care, everybody. Thanks for watching. I appreciate it.